Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we're going to find a standard equation of a conic section hyperbola. Okay, so we're given a piece of information about each hyperbola. Like in the first case, we're given the focus and the asymptotes. And in the second case, we're given the vertices and foci. By using these like pieces of information, we're going to come up with the standard equation of hyperbolas. Okay, so at this moment, I want to remind you about the standard equations a little bit, and then we'll get started. And here we go. So the standard equation of the hyperbola, you have two different kinds, in fact. In one case, the transverse axis is horizontal, and the other case is vertical. And you need h and k, which is which h and k are the coordinates of the center. So as you see that x minus h squared and y minus k squared somehow popping over there. So you need h and k as well as a and b. And a is sort of like the distance from vertices to the center. And you have something called c, which is telling us the distance between each foci and the center. But c doesn't necessarily pop in the standard equations, as you see. And there's a relationship between C, A, and B, and that's C squared equals A squared plus B squared. When you're talking about a hyperbola, you should also talk about asymptotes of a hyperbola. In fact, in part A, we were given the asymptotes, and equations of asymptotes change depending on what transverse axis you're talking about, horizontal or vertical. And to be able to write those equations down, you need h and k, b and a again. And also, lastly, you have the eccentricity of hyperbola, which is essentially the ratio between c and a. So you have to come up with c for given a and b, or once you come up with a and b, then you should use the equation between a, b, c to find c, and then this ratio is going to tell you about the eccentricity. All right, this was a long intro already, but those 3 slides are important. Please have them ready, and I'm going to mention about those in the video again. All right, let's get started. All right, let's start with part A. We're given the focus of the hyperbola that we're after. That's 20 and 0, and we're given the asymptotes, y equals plus minus 3 over 4x. So I want you to check back the formula for the asymptotes of a hyperbola, right? So we are given, so those are given in the form of like k plus b over ax minus h, or minus of that, and the slope can change depending on the transverse axis, okay? But the actual form is just like a number, plus or minus, slope x minus h, x minus another number, and those numbers are in fact the coordinates of k and h, are coordinates of the center, okay? So going back to the first case here, I can immediately see that those numbers are 0, okay? So y equals 0 plus minus 3 over 4 x minus 0, implying that center is just located at the origin, okay? And focus is given as 20 and 0, so we're going, center and focus are all located on the same line, okay? So seeing this, that the y coordinates do not change, that I can see that, so the transverse axis has to be horizontal here, okay? Because you're just moving on the x direction, okay? So in other words, I'm going to go ahead and write here that transverse axis is horizontal, okay? When the transverse axis is horizontal, going back to the form of asymptotes, okay? So here we go. We are in this case, the very first case, okay? We are in the very first case. So that slope is written as b over a, as you see, okay? Slope of the asymptotes are b over a. So going back here, so I can just say that b over a should be 3 over 4. So b equals 3 and a equals 4. Okay. Or in fact, these are the ratios. So let me just keep it this way because otherwise that wouldn't be correct. We could just say here, because we don't know exactly what the numbers are, but we know the ratio, I can go ahead and write this that b equals 3a over 4. So 3/4 of an a, of the a is exactly equal to b, okay? And from the focus, I can immediately see that the distance, well, we have 20, 0, and 0, 0 for focus and center. So the distance is c, right, from center to focus. So that tells me that c equals 20. Okay, that's good because now I have the relationship between c and a, right? C squared equals a squared plus b squared. Okay. And this is a squared plus b is 3/4 of a, so it's 9 over 16 a squared. And that has to add up to 400 because that's 20 squared. Okay. So this implies that 25 over 16 a squared equals 400. Okay. And simplifying this equation, so it's like 16 times 400 divided by 25. That takes you to, let's see, a squared equals 256. Okay. And a comes out of this as 16. Okay. And 3/4 of this is b. So in other words, multiplied by 3 divided by 4, that is 12. Okay. All right, I think now we are in the position of being able to write down the equation of the hyperbola, right? Because you have x minus, let's see, the major axis is horizontal, so, I mean, transverse axis is horizontal. So we are in this case, right? So x term is going to come before y term, and then the bottom squared for the first one is a squared, okay? So here we go, x minus 0 quantity squared divided by a squared minus y minus 0 squared over b squared, which is 12 squared, that's 144, equals 1. Okay? All right, I think that's all it is. Again, this is kind of like an inverse problem, so we were given some data about, some information about a hyperbola, and we were trying to get down to the equation of the hyperbola. That's exactly what we did here, all right? So this is the end of part A. Please move on to part B to see what I'm going to do for part B. All right, bye.